Good morning. So today I'm going to tell you how to do the friction lab. This lab has two parts. In the first part, we're going to find the coefficient of kinetic friction. And in the second part, we will find the coefficient of static friction. So let's get started. So here is the track all set up. That means it has to be leveled, and I have told you in an earlier lab how to level it using an app on the iPhone. And then we need this pulley, the smart pulley, to be attached to the bottom of this. So we will try to attach it to the bottom of this, turn it around, make sure it's tightened there. And then we have the block with the string attached. The block already has the string attached to it now. At the other end of the string, we have the mass hanger. Pass it over the pulley and make sure this string is completely horizontal. So if you bend down, you can eyeball it, or you can use a ruler and measure the two distances here at the ends. And if it's not level, you can loosen the screw and then change the height like I'm doing now. So I have to adjust it a little bit, and I see that, well, now it is horizontal. The wooden part, it should be touching the track, and we have to slowly add masses to the weight hanger until, right. So I'm adding this mass and it's not moving. Gently place the masses, and then I try to nudge it and see if it's moving with a constant speed. No, it's stop and go, so I go add a little bit more. And in the weight boxes you have all kinds of masses beginning with 0.5 grams, so use those and slowly increase it and then nudge it, and if it's moving at a constant speed, then you got that mass. Just put in a 0.5 gram now, and hopefully that'll take care of it, because that's the smallest mass that we can add, right? So now nudge it, and you can see that it's moving with constant velocity now. It's not accelerating. Oh, it's touching. It touched somewhere, but that's the idea. It should be moving at a constant velocity. It shouldn't pick up speed. It should not accelerate. And then once you get that, take the 100 gram mass, place it on the block, and now you'll have to add more masses on the weight hanger for it to move. So repeat this with the 100, 200 and 300 gram masses. And you also got to do it for the block side. So you got to take the felt side. The bigger felt side, place it. First do it without the mass, then do it with the 100, 200 and 300 gram masses. So for each case, you're going to find the minimum mass required on the weight hanger in order to make it move when you give it a nudge, and it should be moving at a constant speed. Last, but you have to use the smaller sides of both the wood and the felt, and again find the mass required, but this time you only need to do it with the 200 gram mass. Repeat it only with the 200 gram mass for the smaller side of the block, which is again the wooden and the felt side. So that's how you do the kinetic friction. After you're done with that and you get all the data, you got to make a graph with friction on the y-axis and normal reaction on the x-axis. How do you find the normal reaction? The normal reaction is the total mass of this plus whatever is on top of it times g. Let's call this caps M, the total mass. So it would be caps mg. That's the normal reaction, because mg is acting down and the normal reaction is acting up. And to find the friction force, it is the force due to the weight hanger and the masses. So let's call those total little m. Do not forget to take the mass of the weight hanger. Once you get the graph, the slope of the graph will give you the coefficient of kinetic friction. Alright, so next we got to find static friction. In order to do the lab on static friction, again there are two parts for static friction. In the first part, you will have to do the same thing with the 200 gram mass. We are only doing it with the 200 gram mass. See? Once again, place weights on the weight hanger, but this time you are not going to touch the block. You are not going to nudge it. You have to add enough weights on the weight hanger so that the block just begins to move. Just begins to move. So that means you're looking for the minimum mass on the weight hanger that will just make it move without a push. And you have to get 3 trials of this. All 3 trials with the 200 grams on the block. You need not change the mass. And how are we going to calculate the coefficient of static friction? We're going to use the formula. F friction is equal to mu s times n. We know friction, once again it's small mg, and n is caps mg, which is the total mass of the block and the weights. And put it into that formula and find mu sub s. You're going to do it 3 times and you will get the average value, which will give you the coefficient of static friction. So there is no graph in this part. So that is static friction one way. We also got to find static friction in another way. Now this time we do not need the pulley, so we don't need the masses either. So we can actually remove the pulley from there. Don't need the pulley. We don't need the string and the masses either. So I want to see if they'll come out. No. Okay. Oh, I actually broke it. That's all right. We only need the block. But we got to take the angle indicator and carefully slip it in on the pulley side where we had the pulley before. That's what I mean. Okay. So connect it there. And what we're going to do is we have to, this is static friction. So once again, we're looking for when motion just begins, and you will slowly lift this side of the track until the block just begins to move. Keep on lifting it, and you have to be watching the angle as well, because you have to get that angle for which motion just begins. And you cannot nudge it. Okay, so there we go. So I got my angle. But you got to do this with the 200 gram mass on that. And when you lift that track, it's going to fall. So in order to prevent it from falling, we have to use some tape and nicely tape this. And you have to do it 3 times. All 3 times you do it with the wooden side. We're only finding the coefficient of friction between wood and the track. There we go. We are increasing the angle, and there. So motion has to just begin. When you get to that point, you'll have to try it several times and figure out the exact angle at which it just begins to slide down. And once again, we can calculate the coefficient of static friction by using the formula tan theta. We only need the angle. So whatever is the angle, again, do it 3 times, get the average angle, and once you get that angle, take tangent of that angle, and that will give you the coefficient of static friction. So that's how this lab is done. Thank you.